Hello, in this video we will be exploring predictive modeling output from Cognalysis MultiRate using data that we analyzed in the Getting Started video. If we open up MultiRate, we'll notice that there's three panels. The panel on the left deals with where is the data, what are we trying to predict, what fields are we using to predict it. The upper right panel is status of analysis. This is some summary information about relative predictive power of the different variables that are being included in the model. And the lower panel then drills into specific information about each one of those fields. So starting with this status of analysis panel, we've got this wheel that is showing us from high significance to low significance. I'm going to expand this pane so we can see this a little bit better. So this data is trying to, or this model rather, is trying to predict house prices in King County based on a set of data. The most predictive variable in this model is the zip code field. And if we click on that, notice that we'll actually see some information down here in the lower panel. But what we're seeing around this wheel is which of the variables has more or less predictive power. So for example, zip code is very powerful. This last one on the list is less powerful. Also in this upper right panel, we have View Model Fit Graphs button. We can click on this with a completed model and get some information about how well our model is actually fitting on that test data. This particular graph is looking at the test data. We can change it to be training data as well. Let's move it back to the test data. And we have dots here for modeled result and actual result. But we've sorted the modeled result in order from left to right of the lowest to highest. So that's why they're showing up as a line. The red dots are the actual, and those are dispersed around the modeled result. This is actually a fairly tight model, a lot of predictive power within the variables that were being used. And so a few things that you can tell from this. First of all, you can get a sense of the differentiation here involved in your model. You can look at the scale here. We're going from $75,000 home to $7.7 million home. And you can get some sense of the variability around it. For very skewed data sets, such as you might see in property casualty insurance, a lot of the dots will actually be off the top here and not shown because we want to be able to show the differentiation in the modeled result. These red circles are averages within the deciles. So in the case of data that's much more dispersed than this, you can't necessarily tell from just looking at the observations one by one, but by grouping them together, in this case into deciles, we can see how the model performs for similar classes of predictions. If we change to the second table, or second graph rather, on this drop down, we get a dispersion of the errors. The third graph here is the lift chart. So here we're looking at how well our model orders the observations from low result, or from high result rather, to low result. So we're looking at our modeled results on our test data, and we're sorting it with the highest modeled result first, second highest second, etc. And then we're accumulating the actual results. And if we have a good model, we should end up in the early part, the first, second, third, with also high actuals as well. And by looking at the cumulative sum of those amounts, we should end up with an arc here, or lift. In this case, if we just randomly sorted our observations, basically a very poor model, we would be along this diagonal. The top of this blue area is the best that we could do. If we perfectly ranked these in terms of the actual results on the test data, then we would end up at the top of this blue area. And you can see what our actual result is here from this specific model with the black line. This measure that we're providing of a fit called relative net lift is looking at the area with the percentage of that overall blue area that's encapsulated by our model here. And so giving us a measure that we can compare against for alternative models for how well it orders the results. Looking at the lower right panel, We can select from a list. We can also select them from this pie chart. We can also select them from this table for different fields. So let's take a look at latitude here. Latitude was one of the fields that was included, and I'm going to change to table view. We're looking here at grouped data. We've selected latitude as being a grouped field. MultiRate has selected bins for us to try to get even amounts of exposure here. Exposure in this case is just the number of records. So what this is saying is we've got 1,182 records in our training data that were less than or equal to, that had latitude less than or equal to 47.3558. On those 1,100 plus records, our total accumulated price on all of the homes, so the sum of our target variable was 363 million. If I look at the ratio of that to come up with an average home price by bin, and then compare those to each other, normalizing to an average of 1, that's what's in this raw column. So we can see that the raw value for at the highest point here, that we had 1.6 times the average price. The price was 60% higher than the average price across everything. But what happens when we adjust for other variables? Because we've got a number of related variables here. We're including latitude, we're including zip code, we have longitude, also an interaction effect for latitude with longitude. There's a lot of overlap here. They're all telling us something slightly different, but this adjusted is saying, well, first let's take the 1,100 records that we're looking at here and adjust them for everything that we learned about all of the other characteristics. Pick any one of those records and adjust it for what we know about zip codes, square foot of living, grade, etc. All of these other variables, they'll each have factors associated with them. Apply those factors, and that will give us some expectation of what the average price would be. And if we compare the actual price to that, that's what we're getting from this factor. And then this final column, this modeled result, is after applying any credibility adjustment, as well as doing some blending from one iteration to the next, and also potentially smoothing. Typically, I will look more at the graph results than the table results. The same information is shown as what we had in the table, but visually. And so we've got the blue dots are the raw result, so not adjusting for all other variables. Orange dots are after adjusting for all other variables. So you can see the impact. In this case, it's muting the impact that we saw from looking at this variable on a univariate basis. When we start looking at things multivariate, it's considerably more muted effect. And then the black line is indicating what our modeled factors are after reflecting credibility and any smoothing that comes into play here. Going back to the table view, there's some additional information that you can get from clicking on any one of these rows. There's specific information here about how the calculation was performed. So you can go back and audit through the calculation to understand that better. I'm not going to go into all the details here, particularly for smoothing and all that, but again, in the help screens you can find information about that. This graph on the right, though, is kind of interesting, and what that shows is how this particular group of records compares to the overall pool. For this particular bin, we can see that there are more observations that are of low value than the overall pool would indicate, and considerably fewer observations that are high value homes. So looking at this specific group of data, we're saying that we're definitely underrepresented in high-value homes in this latitude band. Looking at this data graphically, also notice the size of the dots here. This is indicating more exposure. This was the result of the auto improve feature being turned on when we ran this, that it actually took the evenly grouped bins and actually broke them apart to give a little better differentiation. Not all of the variables that you look at will have a line here. The reason why we have a line is we're saying that these are related to each other. We're smoothing it, we're grouping variables together into bins, and so it makes sense to look at that on a line. But in some cases, it is going to look like this, where you've got individual bins are actually shown disjointed from each other and sorted from low to high. We didn't tell it that there was any reason to believe that 1 should be similar to 2, should be similar to 3, etc. So it's just going to take these categorical values for this variable and showing the low model result to high modeled result. To see the factors all together, you can go into File, Export Factors. And that's showing us, first of all, a base factor. So that's saying, knowing nothing else about the home, the home is expected to be worth $586,000 if it's in King County. But then we're going to adjust for other variables. All of these factors combine together multiplicatively to give us our predicted result, which we saw in those graphs. But we can also see that if we export our test detail. This is showing record by record in the test detail what was the actual home price, what was the predicted home price. And we can sort on that. Maybe add some commas here first. Let's just sort in descending order on our modeled target. So our predicted value. And we can see what the comparison is between the actual home price and what was being predicted. You can also see our factors for what got us there. So we had our 500,000 base price multiplied by a number of factors. We had a factor here for date, a factor here for the number of bathrooms, square foot, etc. And you can see if there's common themes here. So for example, this value view was high for all of these ones at the top. So that's a good way to understand what you're getting out of your model and how well it actually does record by record. You also might want to share the results of this model with somebody who doesn't have Cognalysis MultiRate. To do that, you can print a report, and we'll just call this King County House Prices. Print that to Adobe. And we'll take a quick look through that. It's showing that same comparison of how the variables did against each other for predictive power, as well as the various fit charts, and then starts with the most significant characteristic, both the graphical view as well as the table. And at the end, there's also some information about what your selections were, where this file is located, what some of the selections were made as far as the iteration control. You also may want to take this model and apply it to some other set of data. That would be in the supply factors to other data. You tell it what that table is. It has to have fields that are named the same as what you have here in the same format, and then where you want that table to be created. Do you want to create a CSV? Do you want to create a SQL table? How do you want to do that? And it's going to apply those same factors. Thank you for viewing this video. I hope it helps you understand MultiRate a bit better, and happy modeling.